7-2, day 2, pre-lesson. So first of all, question number 1, what is a radian? Question number 2, what is pi to you right now? Well, I don't think you'd have an answer for radian. I think you should have an answer for pi. Pi should be 3.14. Now, look at your calculator for radian. Now, if you use one of these handy-dandy calculators, there's a little button right here called mode. So if I turn that on, and I know your calculator or this camera is not going to be able to zoom in on it pretty good, I don't think, but right about here is the word mode. If I hit that button, you're going to see this blinky guy. If you go down 3 little rows, you're going to see an option, degrees or radians. So we're going to get into what the heck is a radian. Now your other calculators that aren't really graphing calculators, but they got sine, cosine, tangent, and all that stuff, you might look for DRG, and that will display at the top of your screen either DRG, degrees, RAD. As you keep hitting that DRG button, it'll just pop up DEG or DRG for degree, RAD for radians, and then GRAD, gradients. You won't learn about gradients until you take calculus. We're focusing on radians. So it's on your calculator. It's important. Why is it important? What the heck is it? Well, whether you like it or not, some mathematician a long time ago discovered something very interesting that set the table for a whole new way of talking about math. And math talks about degrees in terms of radians. So let's dig. So this mathematician took a circle and found the center. And just so you know, if I cut this circle in half, let's start, and I went from A all the way to B, and I asked you how many degrees did I just go? Well, a full circle has 360 degrees. I went halfway, so a semicircle is 180 degrees. Now the lesson is not degrees, it's radians. This is new. So this mathematician said, hey, I know this is the radius from here to here. So it's kind of like they cut this out with a pair of scissors with a string, and then they laid it along the outside of the circle, and my drawing's not going to be perfect. But right there is also a radius, the length of a radius. I'm not saying it's the circle's radius, I'm saying that's the length of the circle's radius. And then, if I connect those two dots, that is the actual radius. So I got the length of the radius because it is the radius, the length of the radius because it is the radius, and then this thing from A to C is called the arc length. Now we'll talk about that more later, but this right here is what we're talking about. I'm going to let that be theta. This is called 1 radian. Now, if you look at it, and I know your geometry teacher said don't go by the way it looks like, don't do that, but I could say, you know what, it looks like about 60 degrees. Now, keep that thought in mind. But if I did that again, my drawing's not going to be perfect. If I did that again, I'm going to put an R there and an R there representing radius. So here is another degree measure, but it is called 1 radian. So I've got 1 radian, I've got another radian, and here's what this mathematician calculated. They put another one in there. Again, my drawing's not perfect, but that's R, this is R, and that's R, standing for radius. But that would make this the same as this and the same as this. So that equals 1 radian. Let's do some math. If this is 1 radian from here to here, and this is 1 radian, and this is 1 radian, well, what's 1 radian plus 1 radian plus 1 radian? Well, that equals 3 radians. Okay? But wait, see this little sliver right here? Believe it or not, there's 0.14 radians there after some really precise calculations. And then this mathematician went, whoa, wait a minute. That means I have to add 0.14 radians to all of this. So what I get, watch this now, here comes a red marker. Remember what this was? This was 180 degrees. Wait a minute, 180 degrees equals, watch this, 1 plus 1 plus 1 plus 0.14 radians. So that's 3.14 radians. Now, remember, what is pi? You know that pi is 3.14. So did this mathematician. So the mathematician thought, oh my gosh, 180 degrees equals, watch this, what's 3.14? That's pi radians. Now I could go off on this wild tangent. You know, back when we learned geometry, circles, what's the area of the circle? Pi r squared. What's the circumference? 2 pi r. That little number, pi, is very significant. It's the key that unlocks the door to all the truths about circles. Fascinating. Then all of a sudden, it pops up again. So this mathematician was like, whoa, I've got a brand new formula that works. So from this, the mathematician built a whole bunch of different words and languages for degree measure. I'm going to show you what I mean. 180 degrees equals pi radians. Now, if I cut that in half, 90 degrees would equal half of this. So they write that as pi over 2 radians. Now I'm going to just abbreviate radians with RAD, and then things just go from there. Now, what if I drop down to 60 degrees? Well, what do I have to divide 180 by to get 60? I have to divide by 3, which means I'd have to divide that by 3. That would be pi over 3 radians. Now, what if I threw 45 at you? That's a 5. Well, this one's pretty easy jumping out at me from 90. Don't I have to divide 90 by 2 to get 45? Which means I'd have to divide that by 2. So that means that'd be pi over 4 radians. Now, is that the only way to get 45 degrees? No. My drawing's going to get messy, so I don't want to draw on it, but isn't it true that 180, you can check your calculator, divided by 4 is 45? So that means I could have just divided pi by 45 and got pi over, or pi by 4 and got pi over 4 radians. There's one more I'm going to throw at you, and that's 30 degrees. Now there's really 3 ways to get this. The easiest way is to think, what do I got to divide 180 by to get 30? Well, that would be 6. So I could divide pi by 6, and I'd get pi over 6 radians. I could have divided 90 by 3, by this by 3, I'd get the same thing. I could have divided 60 by 2, divide this by 2, I'd get pi over 6. These right here are what I would refer to as your automatics. Now, it might not be automatic to you now, but these are things that you're going to need, or you're going to want to commit to memory. So if I say, hey, what's pi over 2 radians? 90. What's pi over 6? 6. Excuse me, pi over 6. 30. What's pi over 3? 60. What's pi over 4? 45. Now, you're not quite there yet because you just learned the darn stuff, but here's a trick. Remember that pi equals 180? So if I put pi in here, that'd be 180 degrees divided by 2 is 90. 180 degrees divided by 3, 60. 180 degrees divided by 4, 45. 180 degrees divided by 6, 30. So when you have radians and you want to convert it to degrees, all you got to do is substitute, every time you see pi, just substitute 180 in there and then reduce it. It's the cleanest, easiest conversion. Now there's more to it. Let me pause this. Moving forward. So, I know it's got a little messy, but right here is your automatic list. Stuff you're going to get familiar with, or you should. Now, in your homework, they're going to give you math problems, and these are the easy ones where they're going to give you an angle measure in terms of radians, and they're going to want it in terms of degrees. Now, if you're listening to the little trick I gave you, this shouldn't be a problem, but I'm going to demonstrate it. But back to here. Remember I said in geometry, they say don't go by the way it looks. But if this is 180 from here to here, 180, this and this and this, they look like almost a third. But this little sliver here says, it's not perfectly a third, but generally speaking, 1 radian is approximately 60 degrees. Now, if we want to get more precise, we know it can't be 60 because there's a little slice left. So it's 1 radian is maybe about 57 degrees. Anyways, leave that alone just so your brain can kind of like, what is 1 radian? So here we have pi over 3 radians. How do you convert? Remember my trick? What is pi? Pi equals 180. So we're just going to put 180 degrees over 3, and that would give us 60 degrees. Same thing here, 180 degrees, because that's what pi is. Pi radians over 4, 45 degrees. Now here's one a little trickier. It's not from our memory bank. It's 3 pi over 4. Well, if you just think of it, there's 2 ways to really go about this. Student number 1 has a tendency to remember things, so they're like, hey, I know what pi over 4 is. That's from our list. Pi over 4 is 45. So this is the same thing as 3 times 45, which is 135 degrees. Other students are like, well, you said just put pi in there, so that's what I like to do, and that's no problem. And so now we're going to get this a little bit more math, but this is 540 divided by 4, and guess what that is? It's 135. So both methods work just fine. These are the easy ones, because all you got to do is substitute 180 in for pi, and then do the math, and it will just spit out your degrees. Now we're going to go the other way in a minute. Converting degrees to radians, degrees to radians, degrees to radians. This is not quite as easy. And here we go. First of all, we need some basic math knowledge before you can understand what I'm about to show you. So, remember this? When we multiply fractions, what do? We cross reduce and we swoosh. So 2 goes into 2 once, 2 goes into 8 3 times, 3 goes into 3 once, 3 goes into 9 3 times. I swoosh and I get 3/4. Keep that in mind. Now look, what is anything times 1? Well, look at 7 over 7 is 1. So I can just say 2/3 times 1 is itself. Now I want to show you something. Pi radians over 180 degrees. This is like a formula. Notice how these two things are equal? That's like 7 over 7. So this is like 7 over 7. In other words, this equals this. So what does this equal? 1. Keep that in mind. Keep all of this in mind. First problem, convert degrees to radians. Well, this one shouldn't be a problem. You're like, well, I remember this one. 60 degrees is pi over 3, so that's just pi over 3. So, they're not all going to come from your memory bank, though, so you need a little trick. This is the trick. So, 75 degrees. You know what? I want to change the way it looks, but I don't want to change what it equals. So what I'm going to do is, remember, I can multiply anything times 1, and I'm going to get itself back. Well, that's not going to convert it to radians, but you know what is? Watch this. I'm going to change the way this problem looks, especially on this one. I'm going to make it 75 degrees over 1. I'm going to multiply it by this. Watch this. Pi radians over 180 degrees. Now watch this. The degrees cancel. That's what I want. I want the degrees to go away. And then now I cross reduce. Well, set 5, actually, to make this easier, this is a calculator